Hello and welcome to yet another interesting conversation from our channel. I'm Alex Bolboaca, coming to you from the Mozaic Works studios, and my guest today is somebody who has been programming for a very long time. He has a passion for words, and he actually has words associated with his name. This will be a fun thing to talk about. Uh, He's one of the best speakers at technical conferences. Actually, I'm really curious to ask him how he does his talks. And I'm fairly sure that we'll have a lot of interesting conversations today. Welcome, Kevlin Henney.
Thank you very much. Glad to be here, Alex.
All right. So first of all, before we go a little bit into your bio, you have an interesting name. I don't know a lot
Yeah.
of Kevlins. What is there a story behind
No.
it?
Well, yeah, it's kind of I've ended up with I all of my names are actually surnames. They're all last names. Kevlin is actually it's actually a last name. It's not a very common last name. It's originally from Ireland. It's from County Wicklow. And it was I believe I had a great aunt whose last name was Kevlin. And then it got used as a middle name all the way down the family. So my grandmother had that as one of her middle names. My father had it as one of his middle names. And then they moved it into first place for me, which is great, except that it launches 1,000 spelling mistakes. You know, it's just that everybody gets auto-corrected. They get, I get the number of emails I get from people who know me that are for Kevin or Kelvin, and they send a follow-up email or message saying, "Yep, sorry, autocorrect," because it's just too close. It's such an uncommon name, and then you put it together with Kevlin Henney, and that kind of becomes internet unique. And so that's quite a useful technique, which my parents were, before the internet was invented, managed to somehow stumble across a unique name.
Yeah. It would be interesting to learn more about your biography and how you started with programming and then consulting, because we've met at various conferences, but we never really had the chance to sit down and had a pint together and chat a bit about these things.
Yeah. So these days I work for myself. I'm an independent consultant and trainer. I do other stuff, reviewing and writing. And during the pandemic, I'm doing all of this from home, which is ultimately, better for the ecosystem, better for the environment, smaller carbon footprint, but has allowed me to actually run workshops in Australia that simply wouldn't make sense to do otherwise. I mean, it's absolutely hell getting up at that time in the morning. But on the other hand, trying to do a flight for that would be awkward. So that's allowed me a different kind of flexibility to what I had before. Normally, outside these pandemic times, I travel quite a lot. Speak at conferences, run workshops at conferences, visit companies. So that's what I've been doing. So I've been working for myself in that capacity for, I guess, about 20 years now. And that takes me across a lot of different kind of market sectors and skills. I think what I focus on most is probably development practices. That would be the easiest way of putting it. Development practices we often associate with TDD, the agile space, craft, that kind of stuff, the code quality side of things, but also into this idea of team knowledge and team work at that level, expressing itself through architecture. So that, I think, goes back to my interest in patterns. I've been interested in patterns since the early 90s, co-authored a couple of books on those. And so that's kind of the area. So I have an interest in programming languages, but also in techniques. How do teams work? How do companies work? Although I'm no organizational guru, these are all the things that I tend to consider to be of interest. So that's what I do. How I got there, before anybody paid me to write any code, I think probably it was at school. How was I? 11, 12, something like that. Kind of started learning about computers. The whole technology thing seemed very attractive, and it was home computers and BASIC and assembler, that kind of stuff. And I never really thought of it as a career, but it was fun. I enjoyed doing that. It was a pleasure, like getting into it and finding out the weird stuff about each machine or whatever. So that was kind of that side of things. And then after university, pretty much as university finished, in fact, partway through university, I kind of realized I probably don't want to be doing the degree I'm doing, though I didn't change it. It's physics. I don't want to be doing, I kind of, the computer stuff's really interesting, you know, AI and software engineering techniques, all these kinds of things were all kind of like at the edge of my vision, and you know, grabbed my interest. And actually, that was the first thing I ended up getting a job. I had no idea what I was going to do after university, and so I got a job as a software developer, as a programmer for a company. Turns out that they did Fortran, and physicists are somehow endowed with this curse of Fortran. And indeed, many of the other people at the company were they come out of university with a physics degree. It's like, well, what do we do? Oh, okay, let's become programmers. So probably half the people I know ended up doing that. And I started getting drawn into it, really, really interested in not just this is a job, but actually the whole domain, everything about it is fascinating. You're making something from nothing. Quite literally, you're making stuff up in a way that is quite different to other creative professions, and is in a way that's quite different to something that is a core, stable, closed body of knowledge. So I found it really attractive, and I thought I want to take this further. So I ended up doing a master's degree, so worked and then did a master's degree that took it even further. And you know, kind of haven't really looked back. And my original motivation for that was I originally thought once upon a time I wanted to do AI, and at that time neural networks were kind of becoming a thing. So I kind of did that. And I guess these days we call that shallow learning, compared to the deep learning that we have capabilities for now. But actually, although that was the path I thought I was taking, I actually got much more interested in the paradigms. I already had an interest in things like object orientation, and structured system and design. And I suddenly thought that the paradigms and the actual creation of software itself was of more interest to me. So I ended up taking that path and really haven't looked back. So that's kind of the road. And I love languages and paradigms and the details. I like the little details. I have to admit, I am attracted to those. They make it that little bit more interesting. They're like seasoning. You know, it's not just software in the abstract. It's not just customers in the abstract. It's actually, I really do quite like the code stuff.
Yeah. So I know you have a passion for words as well, which you mentioned. You have, I think, a Facebook page with words.
Yeah. So I have this. I don't know. I've always been kind of intrigued by words, and I never really thought of this as being somehow related until, I don't know, a few years ago. It started occurring to me that actually there is a convergence here. Words and language, I think, are absolutely fascinating. We are trying to express ourselves, and maybe that's not what we're best at, particularly in software development. We're perhaps not as good as we think we are, except that we keep trying. And as time went by, I realized that when we are focused on software development, we are trying to create systems of meaning. That's what we're doing. And it was this kind of curious thing that I thought that language was quite interesting, and the concepts of language. And I don't know, words, words are okay, but they're etymologies. Every word has a history, and it's this idea of like how every word is a story. Very few words. I think the simple way is people sometimes say, "Oh no, this is not what this word means." Well, that's not how words work. Words end up meaning all kinds of things depending on the context of use. And what dawned on me over time is this idea of like, actually, that's what we're doing when we are writing code. It's not merely a set of instructions. We are actually creating a system of meaning, and we're normally doing it with other people. We're trying to collaborate on a system of meaning. So when somebody says, "Oh, that's just or that's just semantics," we have to ask ourselves, "Wait a minute, what else is there? What do you think it is that we're doing?" Early in my career, I remember working one place where we actually had a copy of the C standard, and eventually I had some involvement in the C++ standard. You kind of get into this whole question of the meaning of things. What are the semantics of this? I also had some involvement in a couple of other standards and interest in a few more. This whole question of what does this mean and how is it used here and what is the context? So it took a few years for me to figure out that it was actually the same interest. My interest in language, spoken language, natural language, is drawn or grows from the same source, if you like, and probably ends up at the same destination as my interest in some of the detail of code of like, well, hang on, what are we saying here? This is not just a name, it's not just a label. When we're struggling for something in a piece of code, struggling to name a test, what are we trying to show here? Struggling to name a class or a function, what does it represent? That's a really hard question. We're asking the hardest question, what does it mean? And it's also that these things have a history as well, and they live within a system of meaning. So for me, it ended up that what I thought of as being quite different, actually the same part of the same story. So yeah, I have this page on Facebook, Word Friday, that originally started because I remember listening one Friday to a local radio station, and they kind of posed this puzzle. They said, what is another word for synonym? Now that kind of is like, oh, synonym, that's a really interesting idea. That what is the word for or what do what is the word that you would use for a thesaurus? Another word, or rather a synonym for thesaurus, because thesaurus is a book of synonyms. Jump and leap, you'd expect to find it. And I suddenly thought, wow, what's a synonym for? Well, I know this one. For some reason, I knew this, and it's synonymicon. And I thought, well, that's not a hard question. And I said, well, why didn't I just put this out? And it was a Friday. So I started it on Twitter, and then I pushed it Google Plus, and then eventually it became a page on Facebook. And I put a lot of other language stuff there. These days I don't post a Friday word as often on Word Friday, so it still retains the name. There you go. There's a history there. But on all the other days of the week, stuff I read to do with languages, sometimes it's funny, sometimes it's deep, sometimes it's political, sometimes it's historical, to do with words and language. I post that. So I keep running that. I still find that to be interesting. So maybe I'm an amateur linguist, but I'm certainly not. I don't have the kind of credentials to be a proper linguist, but I find it fun. And there are people out there who also kind of find it fun. So yeah, that's where I go with that.
Yeah, I've been talking to people before on this channel about these things that I like to write, and I feel that writing has helped me become a better programmer. Like better writing and better programming seems to be connected in some way. And that's why I'm also always curious of asking people who share this passion for words and language. And do you think this happens? And if you think this happens, do you have any idea why this would happen?
I think this happens. I think you're right, because for me, I know that I started writing articles quite a long time ago. In fact, it was very specifically, I was part of the reason I was really upset with the job that I had. I didn't enjoy it. I remember just going into work and feeling miserable, and I wanted to do something that was actually kind of allowed me to kind of like, well, one, say yes, I do know something about software, and two, try and just try and express that, because there's some fun here. There's enjoyment to be had in learning this stuff and putting ideas together. And so I started writing articles, and I don't think I'd ever thought of myself as being. I think I had a mental image from school that I wasn't good at writing and things like that. But over the years, I just started writing more and more and more for user groups, for things that got published in the computing press in the UK, and then articles, and then I had columns, and it kind of built up from there. And the writing, if I look back over time, the writing got better. But also, I found that what we were trying to do there is a very similar thing. We are trying to learn to express ourselves. We are trying to say, well, what do we actually mean? What do I want to say here? What concept is this? And of course, in one sense, programming is a very different kind of thing. It uses a formal notation set, and there's a different flow to the ideas of writing an article or a book or a paper. But at the same time, they share something deep, which is ultimately, what are we trying to say? How do we say it? How do I get a thought from this head into somebody else's head? How do I communicate that? And this. And it's exactly as you say. The more you do it, the better you get at it. What you're learning to do is to express yourself, organize your thoughts. Programming is all about organizing our thoughts. Every paradigm we work with is a system of organization of our thoughts. This is thought stuff. So that's why I think there is a connection. I was and I actually eventually took that into writing. I write short fiction every now and then, and that was a really interesting departure. It's something I kind of thought I wanted to do when I was younger, but actually it was trying that, learning a new thing, because you might say, well, yeah, sure, you can write some English, but writing a story has different mechanics. Again, it shares something, but it's different again. And again, more practice. When you start paying attention, you start getting better. And I think my code and my other writing improved, my presentations improved, everything improves, because all you're trying to do is the heart is this idea of like, what are we trying to say, and how do we communicate it so somebody else can go, oh, I understand, or I understand but disagree, or I understand but have you thought of this, or they're able to add something to it. So I think that is, there's a deep idea there. But I think this year was quite interesting for reasons other than the obvious. I came across two pieces of research in the science and psychology press that actually demonstrated a similarity between or a common core, if you like, to people who are good at linguistics or have an interest in linguistics and programming. It turns out that the common core is not, are you a mathematician? The kind of the traditional one is, if you're a mathematician, you're right, you're suitable for programming. That's the kind of the 1960s, 1970s way of looking at things. And with no disrespect to all the mathematicians out there, and this is somebody who qualifies doing physics, so I obviously clearly need to be careful what I'm saying here, but no disrespect to mathematicians out there, but honestly, mathematicians don't write code that much better than anybody else. Sometimes it's possibly worse because they think that they can do it without practice. They don't recognize that there's a whole separate discipline. It's not a sub-discipline of maths. It's actually a separate discipline in which maths may inform it and play a role. But actually it shares more in common with linguistics. The people who are thinking about programming problems, kind of like put them into an MRI, watch their brain light up. It's just like, hey, that's like they're thinking language, not like they're thinking mathematics. So that for me was an interesting one, because often people say, well, programming language, this is a discussion I saw last year on Twitter. It was, is programming language, is that a valid metaphor? Should we be thinking of it as languages? And I'm absolutely, they are clearly different languages, they are different systems, but they have a lot more in common than they don't. And it turns out that actually there is some truth to that, it seems.
Yeah, I remember that I was very good at grammar in school, and that was I think part of. And then I learned that the grammar that we were learning was fundamentally the structured grammar created by Noam Chomsky, or discovered, which is fundamentally the same theory that led to compilers and.
Yeah, exactly. This is the thing, is I actually read some of Chomsky's work, and although the question of a universal grammar is an unresolved question, it's a nice theory, but it's not necessarily, and it's actually quite difficult to understand how it might have come about through evolution, and there are a number of questions about it. But as a lens for understanding something, rather than it being like a theory of physics or something like that, it's a really interesting way of looking at the world, and it has given us, all the regular expressions, context-free grammars, all of that. Yep, that's all Chomsky. And so, like you, it was this kind of realization, wait a minute, I know this, but it's from a different source. It's from programming, and actually this is where these things came from. So yeah, I think there's more deep connection. The more you look, the more you see that you can learn something in one domain and transfer it to another.
And another thing that I noticed is I started using more and more a thesaurus when I'm trying to find names in my code. And this actually leads to more precise naming, to better names, and so on. There's a connection there between the things that you learn and actually.
I think
please.
Sorry, I think there's a point there about using. I think there's a really important point there about being comfortable looking up something. So actually, I think one of the most important things to learning is admitting that you don't know something, or rather, there might be a better way to do this, and then going to something else. And it's not necessarily always that the thesaurus will give you the answer, but it will cause you to think. It will make you ask questions perhaps you wouldn't have asked before. And you go, well, actually, these words are not the words I need. But now I'm looking at them, I understand why I understand better what it is that I need. It's not these, but it is something else. But it gets you thinking. It's an empirical activity. You're investigating, and you're trying to find a solution. And I think that's very powerful. And I think it's not something we acknowledge as much. I think sometimes that idea that a developer, I've heard managers and of managers who sort of said, well, that developer doesn't seem to be very confident because they're always looking things up in books, or you can always see their screen. They've got Google there. They're always looking things up, and it's just like, well, don't they know the stuff? It's just like, no, actually, they're looking. I look up stuff that I think I know, and not just stuff that I don't know, but stuff I think I know, because there's always another point of view that I probably missed, and it's good to be reminded of that. I also find that when I reread things that I previously read, you retain a lot less than you think you do. You go back to the source and you go, oh my goodness, all of these other ideas that somehow at the time I didn't remember. So I think it's part of reinforcing your learning. So that idea of being able to go to something and say, I'm interested, I need to find something else out, whether it's online, whether it's a physical book, whether it's just talking to somebody, looking at a YouTube video. And then it's just like, oh, even if you think you are an expert, you should not consider yourself above this. I think that's a really important idea. And you normally get further along. You understand yourself better. That's what I'm trying to say. That's the right name. That's the right structure here.
Another thing that comes to my mind when I think about comparing writing to programming is for writing, we have manuals of style that are rules, sometimes very useful. Some of them are not as useful and have been historically applied but have expired in the meantime, or are not so interesting. But there are still some important rules that apply today, like use a minimum set of words, or keep short your sentences, or do these kind of things. And I was thinking, have you ever thought about how this kind of manuals of style apply to programming, or could apply to programming?
I've thought about it. I've never gone all the way to saying here is a set, or trying to really investigate that. But I think I was quite influenced early in my career, because by a nice little coincidence, is that there is the Elements of Style by Strunk and White, which is kind of like early to mid 20th century book on writing style, more commonly known in the US than outside it. I was given a copy of that, and I found it really interesting. So I've got a whole load of style guides, because I just genuinely didn't think I knew how to write. So I ended up learning by reading lots of style guides. And you start absorbing stuff. You obviously have to do stuff, but you start absorbing stuff. But it was a lovely little book, and I do recommend, if anybody is out there, get the third edition, not the fourth edition. Third edition is under 100 pages, and it's more elegant, and it feels nice in 20th century, But early in my career, first job I had after university, the one I mentioned, Fortran, they had a bookshelf there of old books, and one of them was the Elements of Programming Style by Kernighan and Plauger, and I read that, and it was based on the idea of the elements of style, and it cemented in my mind this convergence between these two. And I made loads of notes, because this book was not mine, and only a few years later I got myself a copy, because it was so influential on me, and it was still it's a good piece of writing. It's also a nice piece of history there. It was actually quite influential on a lot of developers, published in the late 1970s, and so I think there are things that we can do, and I think there are, but I'm hesitant, because it's very, perhaps we have a little less agreement sometimes about something, but it's not always clear that that's the right way to present it. But certainly style and paradigm and convention, these are all strongly related, and there are guidelines that we can say, there are certain guidelines we know, we understand, we might not follow at certain times. But by and large, on the whole, following them tends to lead to better programming. And it's trying to find the right set, because I think the other problem that we have is that with developers, there are so many different languages, and we're trying to offer a set that is common to many people. The conventions of what constitutes good spoken English and good written English are slightly different. good written English versus, say, good written Finnish are going to be completely different. They might share some broad themes, but there's clearly a lot of differences. And these days, programmers work across so many different languages and paradigms, it's sometimes difficult to know how to structure that advice. So I've often tried, and I will offer people advice, but I'm very cautious about like a one set. But then again, we see the same in writing. I've lots of different books on writing style. They're all presented differently. They all have different ways of looking at it. They also contradict each other. And sometimes that contradiction is something deeply felt in the author who put the book together, or it's actually a reflection of the time. What we consider to be good writing style now in the 21st century is actually quite different to the conventions of the 1950s. When we talk about fiction, what is considered to be good and compelling fiction and story is actually quite different again through the ages, and we see it right across the board. And again, there's something there that we see in programming as well. What was good in the 1970s as good code probably wouldn't pass as good code now. Like the Unix kernel, I've got a copy of the Lyons book on the Unix kernel. This is the 5th edition, I think it was. And you look at that code, and it's C from the 1970s. And you look at that and you go, well, that's not how we write C now. Well, that's not very good C. And then you pause for a moment and go, well, actually, compared to what was being written at the time, this is good. And then you look at it again, you go, and actually, compared to some of the stuff that's being written now, this is still better. It's just we have a stronger opinion about sets of styles, and we've had more of a conversation. More people have talked about it for longer, so we have a deeper sense of that than we used to. So yeah, I think there's a lot of parallels, but again, I don't think there's any one lesson to draw from it, except that there are parallels. I think people will continue to offer different, or use it as different inspiration. Let's put it that way.
Yeah, one thing I like to point to programmers is that everything that we have in our code is actually names. It's either names that we gave or names that another programmer gave. And
yeah.
if you remove the names, if you just replace them with gibberish, you don't understand anything anymore. So at least there's something there about this.
Yeah. It's similar. It's interesting. That's similar to something that I point out to people. Although I tend to do it as three things. I say basically all you've got is you've got names. You've got punctuation, and you've got spacing. And the punctuation is dictated pretty much by the language. There's not a lot of variation in that. You can argue, do I need semicolons when they're optional? Do I need an extra set of parentheses here? But really, that's very small space of variation. Spacing, again, there's not a lot you can do with that. There's a few well-recognized conventions, but that also has meaning. And then I say, and then there's names. And it's just like, that outweighs the other two compared to the punctuation and spacing. Names are just huge. They're dominant. And it is a form of communication. And so, it's something you have to come back to.
Okay, so before we move on, because you mentioned paradigms of code, and I like to discuss about this, but you have a word that's named after you. So
yes, I do.
That's an interesting thing to.
Yeah, so that's kind of an interesting. That's kind of an interesting thing that I've kind of always been interested in. This I don't know, probably since phones started having cameras. I started taking photographs of software failures because software is everywhere. So in the early 2000s, I would be taking screenshots. And using my camera phone, so back 2005, 2006 onwards, I guess, started doing that, started collecting some, and then some people started sending me some if they knew that I was doing this. And if I was running a workshop or a course, or it was a break at a conference and I was going to be the next speaker, I'd sometimes just put up, sort of screensaver style, here's some failure photos, because I think it's interesting, because there's this idea of I think we always like to think, oh yeah, everything works, but it's just like, no, we are creating. I think the way I always put it is, we as in software development, we are the largest creators of incidental installation art on the planet. Wherever you go, you're going to see something. It's like, oh, that's art. It's actually it's a Windows update screen. It's a Linux kernel panic. It's something. You're seeing something failing, and it's interesting because at that moment it breaks the illusion. So all software is about creating an illusion, which is why I think sometimes there's this idea. I think there's an interesting crossover with fiction. We're making stuff up. We're ultimately trying to create an illusion that somebody else believes something that isn't actually true. And we're trying to convince somebody that, yeah, this is a device. This is a television. Actually, no, it's a web browser that happens to be streaming a video. And we are giving you that illusion. This is a chess machine. It's not a chess machine. It's a universal computing device that has been programmed to play chess. And so but whilst you are working with an application on your phone, on your screen, it has its own little universe. You are in that universe. You are reading the news. You are not looking at a computer. You are reading the news. You are doing all of these things. It's supporting an illusion. And when software fails, that's the illusion breaks. And what's really interesting is you get to see something about how it was made. You go, oh, right, okay. So this is running. You can tell this is running JavaScript, or this is running Apache. You can tell in the stack trace, and it must be using this version of Java. Or I wonder if they patched that security gap, that's a common error class in C++ where this has failed. I wonder if that means that they're not testing for this, or that they're not using static analysis. You start theorizing about it. The failure tells a story. It shows you how the system was made, something about the system was made, but also how it was unmade, where it failed. So that was my interest, and people started catching on to this. And then people started sending me more and more. And then we hit the social media era. And people would now share it with me. And on Twitter, they shared it. And I started retweeting it. And then sometime around 2015, 2016, I can't remember. It's possible for me to find it. But a couple of people started saying, oh, I saw a Kevlin Henney at the airport. A Kevlin Henney screen. So then from that point on, it started becoming... And that was quite interesting. It started picking up there, and it's made its way into the register and even Urban Dictionary. It's kind of like funny. It's like my name is now associated with failure, and I think it's an interesting convergence in the sense that I have an interest in things like unit testing and software quality. That I do have these interests. So I'm not pushing it away too far. I think it's fun. But it does mean that I get to see. People will show me these things, but it's also a reminder of like how much software is in our lives, and sometimes the problem is not directly within an application; it's within the environment. But it tells us we need to be careful because the world is running on this. The world is running on stuff we've made up. The world is running on these illusions. We need to be a little more careful in the construction of our illusions.
So you mentioned a few practices, and you mentioned that you are working with teams on applying practices like test-driven development and so on. What is your experience with adopting test-driven development, and what is the stage of adoption? Because what I know is I know people who are saying they do TDD, but basically are writing tests after. I know people who are kind of trying to do, but it becomes very difficult. The legacy code problem is a big problem when you want to start doing that. So give us a bit of an image of what you see.
Okay. Well, I don't see, there aren't as many people doing TDD as say they're doing TDD. That's your observation as well. But one of the things, and I end up doing quite a lot of TDD training, and but I always make sure that what I try to do is communicate that there are two ideas here, one of which is perhaps more valuable than the other. And interestingly enough, TDD is not the most valuable idea that I teach on a TDD course. It's this idea that often gets folded into TDD, but should be separated. And so I use a term that originally Alistair Coburn coined about 12 years ago, GUTS, good unit tests. It's this idea of there is how you produce something and there is what you produce. And there are two aspects when we start talking about the testing side of things, and they deserve to be separated out. Obviously, they go together in time in some way. They're not completely independent, but they deserve to be treated differently. There is how do I test? Well, TDD is one of those, is one answer to that question. I happen to think it's a very good answer. And my goal normally with TDD, with training or coaching, is to get people to at least try it, because a lot of people have a lot of opinions about it. It's fine to have opinions, but then they make a lot of decisions about it, and having never really seen what or felt what it's about. So the first thing is try it. Actually try it. This is and if we're doing a training course, that's even better, because you can say, well, look, there's no point in going on a training course just to do what you already do. The whole point of going on a training course is to do what you don't do. So I say to people, at the end of this course, you don't want to do TD. That's absolutely fine. I'm not your boss. I don't want to. You should be forced to do anything you don't want to do. But I want you to have an informed view about what you're doing, and you should regard it as there is a landscape of ways that you can test something. And if you only know one part of that landscape, you will be stuck with it. You might have opinions about all these other ideas, but there's lots of different ways to organize your tests with time. And that's what we're talking about, the relationship between tests and time. But I do then say is like, and actually the really important thing, again, I think the test first approach is important or it's significant, but for some people, the biggest change is do it more continuously. In other words, break down the size of the time that you're dealing with. That it's actually probably more important if you are testing at the end of some major release cycle or something. Actually, the biggest difference you can ever make is to use shorter time slices, to switch and basically say, oh, I've got my test window open. I've got test code in one window, production code in the other, and I switch between them. And maybe I do test first, maybe I don't. But if somebody says, what did you do yesterday? Did you write test code or production code? And your answer is yes, because you haven't got a separated out model. You don't say, oh, I spent this block of time doing this one and this block of time doing that. Bringing them together is one of the most important things about the time thing that you can do. Sequencing offers you another refinement, first or second, but that's the biggest thing. So in other words, the smaller cycles. But then the other aspect is, what is it that you check in? What is it that the next person will see? They won't see TDD because that's ephemeral. That was the thing you did in time. That's lost. Here we have a record of the tests. You're going to gift those to somebody else. You're going to communicate, which takes us right back to what we were talking about before. What is it you're trying to tell yourself or somebody else about what you're doing here? And that starts getting us saying, well, what makes a good unit test? Maybe I'm doing the test first practice. Maybe I got the mechanics right, but then I look at my tests and I don't know what I'm seeing. Maybe somebody else has said, well, I TDD'd it. I did all the good things, but it's terrible. It turns out that they've not necessarily, there's another part to it, which is what is it you are leaving behind? And so I tell people, whenever I run any kind of training, I said, that is the most important thing. You walk out at the end of this and you understand that maybe testing for you has changed from what you thought it was. And that now you realize it's an act of communication. And in fact, in some places I tell people, my goal is to make you uncomfortable with everything you used to write as tests. Yeah. And I actually did have somebody, and I said that after somebody came up to me at a conference, and I'd run a training course with this company. And then I'd done some follow-up with them. And the guy said, you know what, you caused me a real problem. When I went back to our test suite, I couldn't look at what we had because I knew how much we had missed an opportunity here. I felt uncomfortable looking. These were not good tests. These were not guts. These were not good unit tests. So the thing that I gave him was discomfort with what he had, So I thought, actually, that's an interesting way of looking at it. So for me, there's that side of things. And I think when we start looking at that, and we look also what's happening in things like the BDD space and so on, I think that is having a much bigger effect. I think the idea of what it is we are trying to say with our tests is that I think there are more people doing better things than, say, doing just the straight TDD thing. I think sometimes we narrow it too much. So I just think, TDD, that's great, but ultimately that may be just a little bit beyond where you are now. But could we just change what you are testing and the way you are thinking about communicating it? Could we just make the time slices a bit smaller? Could we make something possible that was perhaps not as possible? And maybe TDD is your goal and you don't get there, but somehow you improve everything else on the way, then that's brilliant. Our work here is done, So that, whereas I think perhaps when I was younger, I started thinking, we should TDD everything. I think it depends on the team and the code base about the strength of that recommendation. I always tell people TDD is the thing you should try. Whether you want to continue doing it, that's a separate question. Make your test communicate. That is the thing I will always kind of insist. You have a choice here that really I don't think there is. You shouldn't consider it a choice. You should consider it as that's what we are going to try and do. So I think on those that's kind of how I relate to those concepts in the TDD space.
And another part important to this is another practice is refactoring. And
Yes.
here there are a few questions when people are doing refactoring. How well do they know the mechanics of refactoring? Can they refactor code that they don't understand, or can they refactor code they do understand? What is the result of refactoring? And I'm curious again to see what you see in teams that you work with.
Yeah, so I think that's an interesting one, because I think that, again, the refactoring story I've followed since the late 90s, when I first heard about XP, and when I attended a workshop by Martin Fowler back at the beginning of 1999, and I was absolutely fascinated and intrigued and excited by this whole approach, because it was actually something that related to my first job, where I was trying to deal with some legacy, and I was really trying to, and I thought, why is it that we are not applying to our code ideas that are very common in maths? When we talk, maths is not the, I said, one of the things we're taught at school is how to simplify things. Here's an equation, here's how to factor it, so that you can understand it better. You can say, oh, the roots of this or that. And I thought, why aren't we doing this in code? Is it that nobody's ever applied this idea? And I talked about it as factorization. And then years later, they have this kind of like whole thing. It's just like, oh my goodness, people have been doing this stuff, and it's much deeper and more powerful than I even imagined. And even without automated refactoring, there was a kind of a rigor that people like Bill Opdyke and Martin Fowler and Kent Beck brought to this. Is just like, no, we have names. Again, names, they're really powerful. I can now communicate something really, they associate that and with a particular discipline. So we automated some of that. Some of that can be found in IDEs. Most languages have very good IDE support for this, but I still left with questions, because when I look at some code bases, you're kind of going, you could just a quick shortcut and this would be tidy. A quick shortcut and you pull this one out. This is the thing that I always struggle with, is that we can actually pick a language here, Java. Java grew up with refactoring. It's kind of the refactoring story, the refactoring, the unit testing, as it were, in modern development. The refactoring and the unit testing story is so closely tied with Java's story. And yet there's Java legacy. How did this happen? Do these, it's just like you're looking at screens in methods that are screens long. It's just like, you do know that it's just like, and extract method, rename. And so it turns out that the availability of the automation was only part of the solution. It turns out that it's not as important as we think it is. For some developers, they'll disagree with what I'm saying there, because they use it every second. I'm not talking to those developers. Those developers are, you do more of what you're doing. It's an awareness. The fact that something is there is not enough. And I don't think we're teaching the refactoring side of things clearly enough. And if I look at my own approach, I'm guilty of this, because I've kind of assumed, TDD involves refactoring. When I've talked architecture, I say, and there's refactoring, and I've kind of assumed that everybody's kind of understood that. But it turns out that there's a lot more depth there. And I actually ran a refactoring last year or so. I've actually been running a couple of refactoring only workshops. Of course, in fact, it was all triggered by refactoring to immutability. It was, how do I take a Java or C# body of code and move it towards something that eliminates or reduces the amount of mutability, so that we are dealing with less state change and code that we can reason about more comfortably, code that is more concurrency safe, code that probably has less bugs, it's easier to test, all this kind of stuff. it actually turns out that the most interesting thing in that course is not, or that workshop, is not actually the immutability, it's the refactoring. I've ended up having to put a lot more material in than I had appreciated, because people have it available, they have their menu options, they have the shortcuts, and they're either partly aware of it, rename being the most popular perhaps, but they don't really have a system for it. They've not really integrated it into their design thinking. And so for some people, it is just that. And then I talk to other people, and refactoring is this huge thing. It's this impossibility. It's, oh, we need to have a whole sprint for this. So it's kind of like, actually, we're trying to say it exists in the middle. It's bigger than shortcuts, but it's smaller than that. And I'm thinking that that's where we need to kind of concentrate our efforts. It's part of a style of thinking. It's not just like having it's not just a simple tool. It's a system of thinking that can be supported by tools. And perhaps we need to get better at talking about that system of thinking. I think that bit might be missing.